I'm here to share a few framework slides, not too much about what we do. And I just try to point out my life's journey, all the colors you can see, different domains, metallurgy to software to mechanical, and now I'm mostly in medical domain. But I'm here to talk about academic research to industrial translation. And all my journeys in life in the last 30 years, I could see a big fat wall. And I'm remembering one meeting where our previous director and me were waiting for a meeting like this to start. And he said, Professor Ravi, I'll tell you, it's going to be the same meeting. Academics and industry will just crib about each other. Academics will say industry is not forthcoming. Industry will say academics sit in ivory towers. Academics will say industry cannot think long term. And industry will say what they do, academics do is impractical. This is standard. It is all over. Okay. And in the current context, which my colleagues have very nicely put, an industry is looking forward for initiatives from academics and industry to expand and take it all over, including SMEs and so on. So I will not talk too much, except I want to make a statement that we are not talking about just make in India by MNC machines, but also made in India, our designs, our machines, our manufacturing, our skills, and at rural level, Gandhi Swadeshi movement is an example of that. The academic, I want to just put some slide. You may throw eggs on my face, but I also represent academics. And I've gone through this process in my life for my promotions. So we have to look for hot topics. We have to prepare and submit proposals for funding agencies. We import expensive laboratory equipment and show it off, saying my lab is a $10 million lab or whatever it is. And then, of course, grants to publish and present in nice conferences in different places in the world. Present in international journals, otherwise we don't get a promotion, and apply for awards and things like that. In the whole process, the common man is saying, what is in it for me? What do I really get out of the whole thing? Now, my experience, fortunately, has been otherwise. I mean, right from IISc, where I did my PhD in 92, so last 25, 30 years, I have been very lucky in working with industry closely, in developing products which are already in use in industry or hospitals, medical domain, and so on. The blue here indicates an academic institute. The red indicates an industry or a startup. The first 6, 7 are manufacturing industry. The last 10, 15 years have been more in medical industry. The Collab DDS is an example of NKN initiative, which Dr. Chidambaram mentioned. AutoCAD also, very fortunate. He's the one who literally turned me around in medical field with the AutoCAD project. And now we are doing a lot. We filed 30 patents in the last 2 years. And we have 10 companies, 10 products going into startups or industry or already used in hospitals. This is just an example slide. What do I know from this? What can we learn from this, which can we discuss here? These are my next 4 slides. The first thing I learned is that academics, we are very happy doing research in our labs to convert an idea into a prototype. Excellent. That's our side. On the other side, industry is interested only if there's a product which is saleable. Then only they will put up manufacturing and distribution networks, because it costs a lot of money. The whole problem is who will take it from a prototype to a product stage. We need to make 10 pieces or 20 pieces to test it, to give it to the sample customers and so on. No one wants to make those 20 pieces of product. The industry only wants mass manufacturing, and that's where the problem is. We're not able to convert academic research into industrial. So we do need, as Dr. Chidambaram and others have pointed out, we do need all the 3 players in this inclusive manufacturing game. And there's one more issue here which I talk about, which is issue of ego, I would say. Academics think that what they do is worth 60%, and it's just 30% effort to convert into a product, and it's just 10% to sell it. What I realize is actually the equation is other way around. What we do in labs is only worth 10%. Please, for heaven's sake, you need to understand that. 30% goes in converting, testing and all that. 60% is building the distribution network and manufacturing channels and so on. This took me a long time to learn. But now I really stand by that. That is lesson number 1. Lesson number 2 is that we are sitting all in islands of expertise. We talk about scientists and engineers and mentors and entrepreneurs. The 4 sides: knowledge creation, product creation, knowledge transmission, and product transmission. The whole issue is that this mental block that knowledge represented by Saraswati and wealth represented by Lakshmi cannot coexist. We have been taught. As academics, we are taught not to think business, not to think money, not to think about earning, not to have large bank balances. I say that there's a time to at least question that. We need to bring them together. But I now realize what Baldev last time pointed out, it needs a lot of effort, lot of energy, so we need to bring Shakti in the middle. So unless you put that, you can't bring them together. This is my number 2 framework slide. Number 3 is that how do we bring these 4 aspects of research and development and education industry together? Who bells the cat? If there is a Chakravyuh, who takes the first step? Okay. After a lot of thought, and I can tell you this is not something I did yesterday. I've been practicing it for 25 years, so I can vouch for it that it works. The first step has to be academic who has to go and visit the industry. By industry, I mean very generic here. It could be a farm or a factory or a hotel or a hospital. Go and see real life. Go and see real life, but then go back to the class next day and tell a story to your students. Usually some student will say, why are they doing like this? Why can't they do like that? And that leads to an idea of a project. And then you just do something, make a prototype, and go back to industry and say, hey, try this out. And that starts a very beautiful, positive spiral of incremental translational research to application to industry. The last I want to share with you is what are the key ingredients for doing this properly in academic institutions. We need three sets of ingredients. The first set is prototyping facilities. I now know that we need metal prototyping, plastic prototyping, but also electronics prototyping, because a lot of products these days need to have electronics and software. We need, of course, design simulation, which my colleagues have spoken about beautifully. We need inspection testing, which Dr. Baldev has spoke just now. But we also need what I am pointing out, pilot batch manufacturing. Okay. The second layer is about the team structure. We need to have totally different kinds of people. I heard in Caltech that they talk about Coliseum, where people collide. A biotech guy colliding with an architect, colliding with a poet, colliding with a, maybe mechanical engineer. These collisions are what produce beautiful ideas and to take it forward. So these 4 ingredients. So I have in my team a continuous stream of visitors who are from all domains. I'm many times surprised to see people in our lab and talking very animatedly about things. But there's a third element, the third layer, which is about culture. So I tell my team people, we are not doing research to put a patent in place or a paper in place. We have to put the face of the end user in face. It could be a patient, it could be a farmer, it could be a hotel manager. Okay, see the face of the guy and do the product for that. That is the first goal. Second thing is we empower innovators. I tell them, don't inform me, just take decisions. Don't ask me permission, just take decisions and just inform me. Okay, and we are all Indians. We have very thin skin. We are very, very sensitive. When someone criticizes my product, I think he's criticizing me as a person. It is not true. We have to think that criticizing idea is criticizing idea. Ideas can fail. People don't fail. Okay, and I tell people, fail early, fail quickly. Don't make a prototype. I have colleagues in IIT who work for 5 years on technologies. They are not shown to the end users potential. I say, how do you know that this is going to be useful? Why don't you show it to someone? Okay, so fail early, fail quickly, get the feedback. All these ingredients cooked in the fire of real life projects is what I think creates good products eventually. That's all I have to share with you. And I want to leave you with saying that that is 1 key ingredients that we need to worry about. Thank you so much.